Hi students, your homework Year 10 was initially due on Friday, but I decided to extend the deadline until Saturday. So now you can submit your homework before Saturday 10 p.m. Right? And you have two problems in your homework. The first problem is basically completing the two-way Anova table that is shown here, and we have done many problems which were similar to this problem. So I am not going to explain how to do the first problem, right? If you follow table 5.3 in chapter 5, if you follow that table and if you read page 170 and 171 from the book, you should be able to solve the first problem very easily. There is nothing difficult about that problem. Now today I am going to explain one problem. So this is the problem that I am going to explain today. Let's read this problem first. The factors that influence the breaking strength of a synthetic fiber are being studied. 4 production machines and 3 operators are chosen, and a factorial experiment is run using fiber from the same production batch. The results are as follows. So basically this is a two-factor experiment, right? The first factor is operator and the second factor is machine, and we have 3 levels of the first factor: operator 1, operator 2 and operator 3, and we have 4 levels of the second factor, the machine: 1, 2, 3, 4, right? And the response variable is the breaking strength of the synthetic fiber. And also, if you note here, there are 2 replicates of each particular experiment. So for example, operator 1 and machine 1, we have 2 readings for that. So similarly, we have 2 replicates for all these different combinations. Now one more thing is, what we are interested here is to see what is the effect of operator on the breaking strength and what is the effect of machine on the breaking strength. So these are called main effects, and we also want to see whether there is an interaction effect between operator and machine, right? So here, analyze the data and draw conclusions, and we're gonna use alpha value of 0.05. So the first thing is we want to enter the data correctly in Minitab. I already entered the data here in Minitab. So you can see in first column I have factor 1, which is operator. In second column I have factor 2, machine, and in third column I have response variable, right? And if you see here, operator 1, machine 1, and I have the reading for the breaking strength. Then the second replicate for the same combination, operator 1, machine 1, and I also noted the reading there, right? Similarly, you can see combination 1 2 1 2, combination 1 3 1 3. If you go down, combination 2 1 2 1, and the related breaking strength. So once you enter the data, again we will go to stat Anova, but this time we will select general linear model. Basically there are 2 models we can select. One is balanced Anova and the another is general linear model. So I will select general linear model. Now first thing you should do is, if you should click on help and read the description about the model, right? So general linear model, we could have also chosen the balanced model, because what is the balanced model? Balanced model says that our experiment is balanced, right? And so let me close this and go to stat again, go to the Anova, and let me choose balanced Anova. Click on help. So see here, they have provided instructions when we should use balanced ANOVA. It says use balanced ANOVA to perform univariate analysis of variance for each response variable, right? And the design must be balanced with the exception of one-way designs. Balanced means, we already studied what is balanced experiment, balanced design, right? Balanced means that all treatment combinations must have the same number of observations. If that is not the case, then we can use general linear model, right? In this case, we can use any model because our experiment is balanced, our design is balanced, but I will use general linear model because that is a general that can be used for balanced as well as non-balanced designs, right? So first step is to enter the data in Minitab. Second, we go to stat, open general linear model, and we have to define, before we can solve this problem, we need to define what is the response variable, what are the other parameters. So in our experiment, the response variable is in column 3, breaking strength, so I am selecting that as a response. Now model, I will again click help, and you can see here they have also provided information on responses, model, and random factors, right? So responses is select the column containing the response variables. We did that. Model is specify the terms to be included in the model. See specifying a model for more information. So I will, if I click here, I can see more information regarding that. So what we want to include is two factors crossed. So we will so what does that mean? So basically we want to include factor 1, we want factor A or factor 1, we also want to include factor B for the main effects. And then if you see the rule here, star indicates an interaction term, so we want to also include the interaction between A and B, right? So we will include A star B. So I will click on model. Definitely I want to include operator. I also want to include machine, and I want to include the interaction between operator and machine, right? So I will click operator again, then star and machine, right? So now we have entered the model. The response says there are no random factors here. You can read more about random factors using the help. Here you can see random factors, more information on that, but in this experiment we have no random factors. Now let's see, we want to plot some graphs as well. So the main important graphs are, we want to check the normality for the residuals, right, as we always do. Then we want to plot a graph of residuals versus fit. Fit means predicted values, right? Then we want to plot the graph of residuals versus variables. So basically I want to plot residuals versus operator. I also want to plot the graph of residuals versus machine, right? So 4 graphs I have selected. Also, if you look at page 178 of your book, you will see these 4 types of graphs that I am plotting for this example. You will see similar graphs on page 178. So that is that. Next, I want to actually in your problem they did not ask for interaction plots, but in your homework problem to answer this part here, under what conditions would you operate this process, for this part you will have to plot the interaction graph. So I will also show you how to do that. So again we entered the data, we selected general linear model, we defined the responses and the model, we selected normal plot of residuals graph, residuals versus feeds, then residuals versus operator and residuals versus machine, and the next is interaction plot. So I clicked on factor plots, right? You can plot many different graphs here also, and you can study more about this particular window by clicking help. It will tell you about main effect plots, interaction plots, but I am interested in interaction plot. And what interaction I am interested in? I am interested in interaction between operator and operator and machine, right? So I selected operator and machine for the interaction plot here, and you can give the title and do other things, and then click OK. Now we are ready. Now once we hit the OK button, the Minitab will do all the calculations. It will show us the Anova table, basic Anova table. It will show us the different graphs that we are plotting, and also it will show us the interaction plot. So I click OK here. And let's see the Anova table first. So here we have a Anova table, right? The first row is operator, second is the machine, second factor, third row is interaction between operator and machine, and fourth row is residuals. Now for operator, you can see the p value is 0, almost 0, which is less than alpha value, right? That means operator is a significant factor in our model. Can we say same about machine? P value is 0.389, which is greater than alpha value. So no, machine is not a significant factor. Interaction, for the interaction between operator and machine, we have a p value of 0.151, which is greater than alpha value of 0.05. That means interaction is also not a significant factor. So in this model there is only one significant factor, and that is operator. So basically what does that mean? That means the breaking strength mainly depends on the operator. It doesn't depend on the machine. It does not depend on the interaction between operator and machine. It only depends on the operator. So that is the conclusion. Now let's look at the different graphs that we have. This is normal probability plot for the residuals, and you can see they are nicely around this straight line, so assumption of normality is good. Now let's look at this plot here. This is residuals versus fit, right? And you can see as the breaking strength increases, the variance is slightly increasing. You can see from this graph. And let's look at the interaction plot. Basically, from our Anova table, we already know that there is no interaction factor is not significant. So you can see there is no clear trend suggesting interaction is important. But if interaction would have been important and we were asked to analyze this graph, what would be our conclusion? Our conclusion would be we have a highest breaking strength at this point here, which is the green is for the operator 3, green line, operator 3 and machine 4. So in order to achieve the maximum breaking strength, we would have chosen operator 3 and machine 4, provided that there is a significant interaction between machine and operator, right? So your homework problem is almost similar to this problem. If you understand this, you will definitely be able to do this problem in your homework. So good luck on your homework. Bye.